This is a demonstration of machine learning regression exercise using Jupyter Notebook. We have a CSV file containing medical bill data of some people from United States. The datasheet also contains some personal information of the people like age, sex, body mass index value, number of children, if they smoke or not, and which part of the country they come from, like Southwest, Southeast, Northwest and Northeast. In this exercise, some regression models will be built and trained by using this data so that it can be used to predict the medical bill a person is likely to get based upon her age, sex and other details. So first of all, some basic libraries are imported as NumPy, Pandas, Matplotlib and Seaborn. SetStyle WhiteGrid is to keep the background of the plot grid which looks better. Matplotlib inline is there as Jupyter Notebook is being used. Then the data from CSV file is loaded and saved as dataframe.df using pd.read_csv, and first 5 rows of the data can be visualized using head function. Using describe function, some basic statistics can be visualized, like number of rows, mean and standard deviation of values in each column, minimum and maximum values, etc. Now there might be some invalid entries in the data which can be removed using dropNA function. In this case, there were no invalid entries as number of rows is still 1338. Then some columns of the data can be plotted for better visualization. Here charges have been plotted using histogram, which gives how many people as a group paid how much as an average. The value of bins can be changed to refine or dilute the plot. Next is a scatter plot for charges with respect to age. This plot is interesting. It can be observed that cost increases as age increase, which is obvious. And there seems to be 3 groups for which 3 straight lines can fit. The bottom one might be for some basic consultation and first aid. The middle one can be for minor injuries or illness with short-term hospitalization, and the top one can be for serious injuries or illness with long-term hospitalization. But those are part of data analysis and is a different domain. Now for regression task, the data being used should be in the numerical formats, but here 3 columns are non-numerical and should be converted to numerical first. There are different methods for doing this. Here label encoder from Sklearn is used to assign a numerical value starting from 0 for each category. There are 3 extra columns, so the required columns can be selectively saved into new data frame. Another method is pd.factorize to selectively change each column and save the required columns into new data frame using indices of the columns. Also, concatenation can be used for that. That was the data processing part. Now the processed data can be used for machine learning regression task. For that, first, features and labels from the data is required to be separated. The label or target is charges column, which is saved as Y-full, and rest of the columns as X-full, on which the charges is dependent by dropping charges column from data frame, and 1 is for axis along columns. After that, data is split into training and testing data using train_test_split function from Sklearn_model_selection library. Though the data is split randomly, random state 42 ensures that the data set is same every time it is run. Now linear regression model from Sklearn is imported and saved as LReg. Then training data is fed to train the model using fit function. Once the model is trained, it is validated using training data again, and prediction is done on testing data. Mean_squared_error and mean_absolute_error from Sklearn is used to assess performance of the model. Here, prediction error is visualized with respect to actual charges. It can be observed that error is higher for higher charges. Now random forest regressor model is trained and used to predict in similar way. And the prediction error seems to be better than linear regression model. Similarly, support vector regression model is trained and used to predict. In this case, the model seems to be very biased and highly underfitted. Next, the mean absolute error of the three models is compared and random forest seems to be performing best. Same is the case with mean squared error. Finally, a prediction of medical bills is made using some random person's details. These are the details of the person. Age, 29, BMI, 21, no children, sex, male, not a smoker, and comes from Southeast region. Random forest regression model is used to predict a hospital bill which comes out to be $3,717. Now let's see the age versus charge graph. So, the age is 29 and other parameters seems to be of a healthy person. So, $3,700 seems to be a good guess. Insurance companies are probably using these data to fix a premium for the health insurance or any type of insurance for its customers. And this is making them big fortune for sure. Especially, an insurance purchased by healthy persons for whom the companies have probably very little at risk and a lot to gain. And therefore, they charge seemingly less premium, which in fact is mostly useless for most of them as they will rarely go to hospitals, and that also for very small reason. These machine learning regression models have numerous potential applications in various sectors including cells, stock market, housing, and so on.